Oh, and I got to find my own notes. So this is chapter 1. This chapter, just sort of the philosophy of this chapter, is it's a review chapter. It's like, and then as you get these things done, make sure you turn these things in on your way out. It's a review chapter. It's stuff that all the stuff that you loved from Chem 3A or Chem 1A. Now, oh yeah, how many of you had Chem 1A? How many of you only had Chem 3A? You'll be fine. 90% of what you need to know comes directly out of Chem 3A. So let's do this real quick. It works. Okay. So here's first things: atoms and electrons. So we got a periodic table. If I wanted to know the number of electrons, what do I need to know? Like, let's say it's carbon. Look at carbon. Yeah. This is the valence electrons. That's we got to save that in your head because that's really important. It's the little blue number on the right. Right? The 6. So there's 6 for carbon. Right? Nitrogen's what then? 7. And this is 8. 9. I skipped oxygen. I don't know why I did that, but I did. In fact, carbon, nitrogen, oxygen, phosphorus, sulfur, hydrogen, and the halogens. Those are the ones you really need to know. Okay, but it turns out you're not going to need to know all the electrons. You just need to know the group number, which is the valence electrons. Okay, so I'll talk about that in a second. But what's the Aufbau principle, guy? Anybody remember what that is? You don't need to know the whole thing. It's okay if you don't remember. I'm just going to tell you. It's the filling order. It's like how you put the electrons in the orbitals. So you remember orbitals? It's like 1s, 2s, 2p, 3s, 3p, that kind of thing. That's about all you need to know. It goes on forever, literally goes on forever, but that's about, for this class, that's all you need to know. You need to know that there's s's and you need to know p's. And if I was going to do the electron configuration for carbon, nitrogen, and fluorine, I just have to stick electrons into that kind of shell. We'll consider this 1s, 2s, like they're called subshells, but these things are called shells. We could stick electrons in there, and there's a certain number of electrons that go into each kind of orbital. So I'm going to write that down over here. If I have an oops, sorry. There we go. What do you see? Oh, you don't even see that. Okay, so if I have an s orbital, how many electrons? There's one orbital, 2 electrons. No, that's okay. I'm just guessing you haven't sat around late at night going, man, what was that orbital number? Okay, what's P? That's D.
No, it goes
6. 3 orbitals, 2 electrons each. Yeah, there we go, 6. D is 10. But we're never going to deal, this is organic chemistry, we never deal with d orbitals. We go D's, F's, we don't do none of that. In essence, we stick with the first 3 periods of the periodic table, except for some like calcium and things like that, like the ions, right? Well, I should have probably mentioned that. Okay, anyways. Yeah, in case you get to it, D is 10 and F is 14. And that's the number of electrons. Okay. It's working. It's working. I've been complaining for like a semester about it. It's not good Wi-Fi in this room, and every time I do that, they fix it.
Good.
Yeah, so they're probably going to send me to all the rooms eventually. So we're going to do electron configurations. So let me write this again. It's 1s. Oops, sorry. This one. So it's 1s. Okay. Two s. 2p. That's all I'm going to need for these elements. Let me throw hydrogen in there too, because hydrogen, how many electrons does hydrogen have? 1, yeah, it says 1. So we're going to do hydrogen. So hydrogen's electron configuration is the easiest one. It's 1s1. All right. And carbon will be, well, carbon has 6 electrons, right? And so I'm going to go 1s2, 2s2, 2p, right? And then 6. Or not 6, 2. Because I got to get to a total of 6. So 2, 4, 6. So that's the electron configuration. These numbers have to add to that, and then I have the constraints of like how many electrons go into each orbital. Do nitrogen, and I'll write it here while you're doing that. This is carbon. We'll do nitrogen. And then I'll also go ahead and do fluorine as well. And then you can check to see if you sort of got it. Like that. You guys got it? Yeah? Yeah. You thought you wouldn't remember it, huh? Like, oh God, orbitals and electron configuration.
This has been following me since 3A, so it's just like...
Oh yeah, like a curse, huh? Sorry, I talk like this is my normal like.
Yeah.
I feel it's really nice to have like Chem 8 because even though I haven't taught it in a long time, it's just like you have been through the ringer at least once, right? Yeah, yeah. Some of these guys 1B, right? 1B have been through like a lot of the ringer. Some of you have been through 3A, some have been through 1A, and yeah. So what are orbitals? Okay, so just to say just this, right? If I have a 1, oh sorry, keep doing that. Oh gosh. So if I have a 1s orbital, it's that sphere, that shape, right? And then if I have a 2s orbital, it's the same shape, but bigger, yeah, bigger, because it's energy level 2. And then if I have a 2p, you guys remember what 2p orbitals look like? Like a dumbbell, that's what they say, but it doesn't look like a dumbbell.
One of them looks like a flower.
It looks like this. And that, yeah, those are the ones we're not talking about, so just pretend she didn't say that. That's a p. Yeah, but there are Ds that look like the flowers, and the Fs look like three-dimensional flowers. Yeah, they got a lot more of these, what are called lobes. These are called lobes. You don't really need to know this term that well, and these are called nodes. And this point here, that's where the nucleus is. That's the middle of the atom. The middle of the atom for these is here. The middle atom for those is there. Okay. That's where the electrons go when they're in the orbital. So when you're writing an electron configuration, you're writing like, oh, the electrons are going in the 2s, let's say. Well, they're the shape that they're going into. Hang on. The shape they're going into is that one there. I don't like that pointer. Well, whatever. That's where they're going into. If you're going into a 2p, the 2p, they're going into here. And here at the same time because the electron just sort of fills the orbital, right? The reason this is important only is it's going to become important to understand the shapes of molecules when we start thinking three-dimensionally. And one of the important concepts about p orbitals is there are actually 3 of them. And if you draw an x, y, z, and this may be one of the things, like if you had 3A, you may not have gotten this, but there's 3 of them, okay? It goes like this. So you guys get that, like this is x, this is y, and this is z. So it's Cartesian coordinates like a graph. One sits on the x-axis, one sits on the y-axis, and one sits on the z-axis. Okay? I guess I could choose a different color. And then z, okay, pink. Not in my, there, pink. Okay, so, and then when you put electrons in them, electrons can go into this point, or this point, or this point, and that would be the x orbital, the y orbital, or the z orbital. And then when you think about how bonds are formed, like chemical bonds are formed, they're formed using orbitals. So the directionality, like the direction in space that the bonds are formed, are determined by these. Okay, so that's just a thing to remember. So you all okay with that so far? 3 orbitals, yeah, X, Y, and Z. If something's bonded on the x-axis, right, directly to the x-axis, then to bond to the y, it has to be indirect because the orbitals are pointing like this now, okay? So, all right. Yeah, so I'm going to, this is a, should have been a little more efficient here. I don't know why I thought this was going to be necessary. So I'm going to write the configuration for, I'm just going to do nitrogen, 1s, 2s, 2p, and I've got 2, 2, and 3 like that, all right? So we're going to identify core electrons. Core electrons are everything lower than the highest energy level. So what's the highest energy level we see here? 2. Energy level is this. So those are the highest energy level. On our periodic table, I don't have a laser pointer. I might. Look around. You have a laser in there? Oh, it works. These are the energy levels for organic chemistry, basically 1, 2, and 3. Okay. So I know that nitrogen is 2s to add 2p. I don't know if you learned how to do electron configurations that way, but if you didn't, it doesn't matter. Yeah, those are the energy levels. That's the highest energy level. Those are the valence electrons. Okay. So this is the core. There's 2. We would say the core is like helium, and we would use brackets like that to indicate that. And then these are the valence electrons.
I always looked at it like if there's a 3 on top of the last one, that means it's going to be 2. If there's a 2, that means it's going to be 1.
No, not quite.
No?
No. Let me ask you a question. What does that word look like? Like if you were not in a chemistry class and you saw that word, what would you say?
What core are they?
Like we've perverted your mind so far that it's only valence. It's valence. What's a valence? You may know. You guys aren't fancy, huh? Me either. My wife is, so she's like, she knew all these terms. It's the thing that goes on the outside of your windows. Like you go inside and you have curtains, and there's a little box around the curtain, so you don't see all the rods and the little hangy things. That's called a valence.
The ruffles.
Yeah, the ruffles in front of your curtains. The curtain, yeah, that's called a valence because it's on the outside. So valence electrons are the outermost electrons. That's what you see. These valence electrons are important because that's what the atoms make bonds with. The stuff on the inside doesn't matter so much. Okay, so if I'm taking the valence electrons, all this is to say, I have 5. 5 electrons is the highest energy level. What group number is nitrogen in? 15, right? Get rid of the 10, there's the 5. So if you want to know valence electrons, all you do is you say, well, what group number is it in? And if it's higher than 10, you just get rid of the 1, and that's how many. So if I do fluorine, how many valence electrons? 7. And carbons? And nitrogens? Yeah. And this is how we're going to do all our chemical bonding. You guys catch it? We did that really fast. I know. See this? Carbon's got 4. Boron's got 3. Nitrogen's got 5. Oxygen's got 6. Fluorine's got 7. Now, what about chlorine? How many valence electrons?
7.
It's going to be 7 because it's the same as fluorine. Right? They all have similar chemical properties. We call these groups or families. Right? They have the similar chemical properties. They all have the same number of valence electrons. Now, honestly, if you're going to do electron configuration for chlorine, you got to go all the way to the 3 energy level. If you're going to do bromine, you're going to have to go to the 4 energy level. And there's D's and all that kind of stuff, but nobody cares. They just want to know how many valence electrons there are. When I ask you a question on a test, like how many valence electrons are in these atoms and how many bonds do they make, you're just going to look at this number and say, well, that's got 5, it's got 4. All right. There's so much material in this class. I need to warn you, we're going to just do it. This is how it's going to be the whole semester, if not faster. It's as fast as words come out of my mouth. Sometimes they won't come out of my mouth. They'll just get stuck halfway up and be like, you know that thing. Okay, so we're going to do Lewis dot diagrams.
You raised it.
Yeah, what happened? went the wrong way, I think. There we go. Lewis dot diagrams. I might have copied a slide twice. Let me just double check, because I just rewrote these. Yep, no, we're good. Okay. Yep. Lewis dot diagram. Okay, so this is how you do Lewis dot diagrams. Take number of valence electrons, and you put those dots around the element symbol. Super simple. Okay. So, you determine the valence electrons for hydrogen is 1, right? So we're going to really quickly go through, and on the top of these elements, I'm just going to write the number of valence electrons. It might be a little small, but you can read it off periodic table too. Oops, didn't mean to do that.